Question 10. The equation of a curve is y is equal to 5 minus 2x. Then the whole of it is power 3 over 2, then plus 5 for x less than 5 over 2. And they are saying that part A, a point P is moving along the curve in such a way that the y-coordinate of the point P is decreasing at a rate 5 units per second. Find the rate at which the x-coordinate of the point P is increasing when y is equal to 32. Now, what is given is dy dt. This is an application of differentiation, connected rates of change. Okay, so we have dy dt, which is equal to negative 5, because they said it is decreasing. If it was increasing, then we would have written this one with a positive. Okay, so we put a minus. Now, failure to do this one, you're going to get a wrong answer. Okay, now we need to find the value of x when this y is 32, right? So if we have 32 here, I'm now substituting here. This one is equal to 5, then minus 2x, then to the power of 3 over 2, then plus 5. When I bring this one this side and it subtracts, that will be 27, which is equal to 5, then minus 2x, then to the power of 3 over 2. Now, here I will put 2 over 3 to eliminate this power because they are going to multiply. Just like you can have x squared is equal to 4 and you want to find x, you take the square root. But the square root is the reciprocal of this power here because this one is 2 over 1. So when I multiply by a half, that power disappears. You see that? So it is the same thing that I do here. I power this one with the reciprocal of this power so that it disappears. And what I do on this side, okay, is what I also do this other side. Now, the cube root of 27 is a 3. 3 squared, that one will give us a 9. So we shall have 9, which is equivalent to, of course, this one has gone. Then we have 5 minus the 2x. So I can bring the 2x this side, it becomes a plus, and then 5 here minus 9, which is a negative 4. And then when we divide through by 2, that means x is going to be equal to negative 2. Okay, now we have y, which is equal to 5 minus 2x, then to the power of 3 over 2 plus 5. So I need to get the y dx because remember, this is differentiation, connected rates of change. So we need to get the y dx because it is connected to dy dt and dx dt. So the y dx is going to be, drop this power here. When I drop the power, it will be 3 over 2, then into 5 minus 2 of x, and then this will be 3 over 2 minus 1. That one will give us a half. And then times, you enter inside and differentiate here because this is what we call the chain rule. And we shall multiply this one with a negative 2. Of course, when you differentiate the 5 here, that one disappears, right? So this one automatically will go with that. Meaning this one is going to be negative 3 into 5 minus 2x, then to the power of a half. So now since we got x as equivalent to negative 2, so what will be dy dx? So this dy dx is going to be negative 3 into 5 minus 2 times negative 2, then to the power of a half. What do we have here? This one here is negative 2 times negative 2, that's a positive 4. So positive 4 and 5 will give us a 9. Then the square root of a 9 will give us a 3. And then 3 times 3, that is a 9. So we shall have negative 9 here. And then we are to find the rate at which the x coordinate is increasing. So that means we are supposed to find dx dt. So dx dt is actually going to be equal to dx. Then I can put dt here. But x and y are connected. So I'll have dx, then dy, then times dy dt. So that this one can cancel and you remain with your dx dt. You see that? Okay. Now we have our dx dy is actually the same as 1 over dy dx. Not so? So 1 over dy dx is here, that is negative 9, then times dy dt, which we got as negative 5 here, right? So times negative 5. So that means our answer is going to be positive 5 over 9, as simple as that. Part B, point A on the curve has the y-coordinate 32. Point B on the curve is such that the gradient of the curve at B is negative 3. Find the equation of the perpendicular bisector of AB. Give your answers in the form give your answer in the form ax plus by plus c, which is equal to 0, where a, b, and c are integers. That means we need to get the coordinates of a and b, and we know that a perpendicular bisector passes through the midpoint of that line segment. So we also need to find the midpoint of that line segment. Okay. So first of all, our a, we saw it. It is, let's check back here. A, the x coordinate, the y coordinate is 32, right? When we check here, they are talking about the y coordinate being a 32 for A. And we got the x coordinate here as negative 2. You remember? Okay, now that means when I come back here, A is negative 2, then 32. That one is already good. So I need to find for the coordinates of B. So at B, we said that at B, the gradient of the curve is negative 3. Okay, gradient of the curve is equal to negative 3. So let's go back here and we check gradient. The gradient function, when we differentiated dy dx, we got this one here. So negative 3, then into 5 minus 2x, then to the power of a half. Okay, so I'll go here and I write negative 3 into 5 minus 2x to the power of a half, then is equal to negative 3. Of course, when you divide through by negative 3, that one disappears and we get a 1. So we have 5 minus 2x here to the power of a half. This one is equal to 1. Then I will square both sides, right? Because x is in the square root, so square both sides. We shall get 5, then minus 2x here, which is equal to 1. When you square, this one disappears. When you square this one, still it gives you a 1. Okay. Now, bring this one this side. What do you get? You get 5 minus a 1, then is equal to 2x. This one is a 4. Then divide by 2, we shall get a 2, meaning x is equal to 2. If x is equal to 2, then what is the y coordinate? We go back here and we substitute in here. So that is 5 minus 2x to the power of 3 over 2, then plus 5. So y will be 5, then minus 2x, okay, to the power of 3 over 2, then plus 5. So what do we get here? 5 minus 4, that is a 1. Then 1 power any number is a 1, then plus the 5, that one will give us a 6. So this will be 6. So this therefore implies that our B has coordinates 2 and then 6. You see that? Now from there, they want the equation of the perpendicular bisector. A perpendicular bisector, I said it before, bisector passes through the midpoint of a line segment. Okay, the midpoint of a line segment. So that means we need to find the midpoint of AB. So midpoint of AB is going to be the average of the x points. So we have average of the x coordinates. We have negative 2 for A and then 2 for B. So you have negative 2 plus 2, then divide by 2. And then the average for Y. Y for A is 32. Y for B is 6. So 32 plus 6, that is 38, then divide by 2, that is 19. Of course, this one is 0, so we have 0 and then 19. Now, we need to get M1. That is the M of AB. Change in Y over change in X. So we have 32 minus 6. 32 minus 6, then out of the X coordinate of A is negative 2, and then that one of B is a 2. So negative 2, then minus 2. Here we are getting 26, then out of negative 4. Simplified by 2, 13 by 2, 2. So we have that one there. And then M2, of course, these are perpendicular lines. So that means M1, M2 is equal to negative 2. So the gradient of the perpendicular bisector is going to be negative 1, then divide by negative 13 over 2. Negative divided by negative, you get a positive. So that will be 2 over 13. Then after that, we can now use y minus y1 is equal to m into x minus x1. Remember, when we are finding the equation of a straight line, we need to get a point through which, at least one point through which a line passes and the gradient. So a point this line passes through is 0, 19. And then the gradient is 2 over 13. So we have y minus 19, then is equal to our m is actually 2 over 13, then into x minus the 0. Now, I don't need to open these brackets up, I just need to cross multiply based on the case, the format within which I'm supposed to express this. So we shall have 13y minus 19 times 13. What do we get? 19 times 13, that is 247. So 247 then is equal to, of course, 2 times x, that is 2x. Then I can take everything this side, or this one this side, whichever you want. So I can have 2x, then minus 13y, then plus 247 is equal to 0. And that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.